So the next talk is also a contributed one, and the title is Dialog System Technology Challenge 7, and it will be presented by Chiori Hori.
Hello. So today I would like to introduce DSTC. So this year we have the 7th Dialog System Technology Challenge, and Koichiro, Luis, and Julien, I organized this challenge. And let me look back the history of that DSTC. Actually, here we have a chair of the DSTC. So Jason and Antoine kicked this dialogue challenge. This is because it was very hard to share the data to evaluate the performance using the same platform. So that's the reason why they started from CMU, Microsoft, Honda Research Institute, and actually nuances in there. So, and at the time, best timetable was used for the data set, and then restaurant retrieval, and then tourist information is targeted. And at the beginning, a human-machine dialogue data set was used, and then tourist information, human-to-human dialogue was targeted. And gradually, we extended the target, but this dialogue state tracking challenge is actually to predict the slot type and the slot value. And then, so we would like to predict the system actions. Of course, state transition models are promising. POMDP was proposed by Jason, and everything is drastically changed. But the most difficult part is very expensive. This example shows that tour guide system, the center one, green one is a tour guide system. We invited 100 people. 3 guides tried to let them plan a one-day trip. And we need to transcribe speech first. And then transcription needs to be annotated as with concept tags. And then it is very difficult to train the models to use the consistent annotation. So it is too much expensive. We cannot build that one again. So everybody wants to use the end-to-end dialogue systems. So last year, we changed the names. Dialogue State Tracking Challenge is now dialogue system technology. We would like to cover more wider scope, especially end-to-end technology is focused here. And track 1 is response selection. Track 2 is response generation. And track 3 is dialogue breaking we targeted. And Facebook, Naver, MAL, and TT we prepared last year. And this is an example of the result of the track 2. This is sentence generation. The left bar shows that the human responses, and others are system responses, human rated based on a 5-level Likert scale. Here, we can recognize that our system result is not so bad. At the beginning, I thought that is a grammatically incorrect sentence can be generated, and maybe the context is totally messed up, but actually reasonable sentence is coming out. And sometimes people talk about okay, evaluation metric, blue doesn't work. Actually, this is not the metric problems. That is how much we can cover the ground truth. So if we have the ground truth in our hands, actually blue works, or Levenstein distance, that is okay. So it seems like when blue is very high, the human rating is also correspond to that rating result. And then this year we proposed DSTC 7. So we called the track from the floors. And we got the 3 tracks here. So actually, at the beginning, we were very surprised. 236 people registered. And we also designed the challenge as we did before last year. Track 1 is response selection, and track 2 is response generation. And the third one is much more excited thing. So audio-visual fusion for the video dialogue. That is a new one. And you can show that bar graph. 236 people are interested in 3 different tasks. And it seems like 73.3% people are interested in sentence selection. And sentence generation, 61.9% of people. And for the audio-visual scene aware dialogue, seems like 50%. Okay, so now there's a lot of talk about the task one overview.
So here I am again. This is about the track one overview for this competition. The pictures show the organizers of this, that is the sub-organizers, the people responsible for this track. Chulaka, Gunasekara, and myself were from IBM, and we collaborated with the University of Michigan, Jonathan Kummerfeld and Walter Lasecki, both on the data and on the definition of the challenge. So what is the task? As Chiori said, it's next utterance prediction given a partial dialogue by sentence selection. So you select the correct answer from a list. We released two new data sets. One is an improvement on previous data sets that were produced on Ubuntu IRC channel, which we can view it as being close to some IT support in some sense, so it is close to some real case scenario. And the second one was course advising that were human to human, a little bit prescribed, but quite free flow interactions, giving student advice, a professor giving student advice about what curriculum choices to make. The statistics of what these dialogues were like are shown there. And we produced large number of candidates so as to increase the complexity. We included language variations because, for example, for the course advising data set for each sentence, it was used a mechanical Turk to produce through crowdsourcing 4 to 5 different paraphrases of the same utterance. And then we also included cases where the correct answer was not included in the list, in the candidate list, and so the system would have to say that I don't know, basically. And also we connected it to external knowledge sources, which was in part things that I talked about in the previous talk. So one thing that we did on the Ubuntu IRC dataset, which is well known, and actually there are people here who originally worked and produced on this, Julien and others. So what we did was that that dataset was in some sense dirty, in the sense that it wasn't clear when a thread was starting, who were the speakers, and whether that thread ended. And many times it was, how do we say, very short, like 2-3 utterances, or only one person pretty much talking. So we created a new algorithm that tracks the thread, and from these threads we only picked only two-party conversations, okay? People who were actually talking, two people talking. So these are actual, we extracted them from the millions of the IRC channel, and we created this final data set, and we extended the number of candidates to 100 or 120,000, all the possible choices basically that you could have. So the second thing that we did is the course advising, as I said. This was play acted, that is two students or two people played, one the student and one the advisor. The difference is that the student had a profile about what preference and so on, which was a real profile, and the professor, in quotation marks, had another profile, which was what the courses are, what the curriculum is, what is the current standing of the student, and what others had done in this case. And the idea is to really pick the best next answer. To measure the success in this, we had the recall at some number. So we used the average of the recall at 10 out of 100, and also the mean reciprocal rank. Okay, and we averaged those two to give a ranking for the winning system. For one particular subtask where there were multiple possible utterances, we also used the mean average precision of picking the response. So here I just flashed this. Okay, I'm not going to talk about, we don't have time. The idea is that to show that there were 20 participants. Some of them sent us the description of the systems, and I have included them here. And they ranged a lot in the different technologies. You see different embeddings were used, different architectures, and so on. And you see there the different scores that were gained. The point is that, yes, there were systems that ranked really high, which means that for these tasks, they were able, which were difficult tasks, they were able to do quite well. So, and as I said, and as Chiori will say, there is this workshop that we are organizing in the upcoming AAAI, and I hope to see you all there too.
How are we doing for time? Hi, I'm Chris Brockett. Here are my partners in crime. Actually, most of the work around this was done by Michel, Galley, and Xiang, who deserve most of the credit for organizing this. Our motivation is that something that has been discussed here already, and that is that the end-to-end neural models tend not to be very well grounded. With the conventional dialogue models, the traditional dialogue models, it is relatively easy to tap into knowledge bases and so APIs and so on. But we haven't been able to do this terribly successfully with the end-to-end models, and we're still working on it. So that was the purpose of the challenge. Ideally, what we want to be able to do is take some data from some source, a text source, for example, and be able to hold a conversation around it. We won't address what the purposes of that conversation is, just simply be able to say something intelligent about it. And so we set it up using Reddit, partly because there are ways of accessing large quantities of data using tools that we've made publicly available. We had the participants extract over 20 million sentences from web pages on Reddit that were discussed on Reddit, and ran the task from that. A couple of points to make here. We used multi-speaker conversations. This gives us multi-reference blur for free. The other thing is that Reddit is not actually conversational. Unlike Twitter, where people follow people and so you get social interactions, Reddit is people following topics, and the interactions are less social and more topic-focused than interpersonal. So there is this difference that emerges in the generation. There are 7 teams, 26 systems, a bunch of different technologies. We used automatic evaluation with Meteor, Blur, NIST, and a whole bunch of others. We evaluated on relevance and informativeness to the preceding turn and the topic data. Just posting some results, because I think you might find it rather interesting. Human is a held-out human response. And what you will see is that even on Blur, we only get 3.13%, 3.13%. So there is a kind of an upper bound that is being indicated by the human responses there in this evaluation. The distance between Team B and Team C and E, which was an accidentally duplicated submission, is non-significant. Those two teams that were substantially ahead of the others. And yeah, thank you.
So actually, I have only 3 minutes. Let me, quickly speak about that. Okay, so in our cases, we would like to make a dialogue system which can be available for the robot. So we collected the data on video. So it is very difficult to collect the data itself. So we collaborated with Georgia Tech, and Devi and Dhruv's group are hardly working on that task, and we are very happy to collaborate with them. And this is the idea. Okay, so they look at the 2 robots, but he said that's a cool robot. In his mind, R2D2. But of course, C3PO has only flow or RGB and no idea about it. And then, so he needs to understand this is a kind of video description technique. So he understood there are two robots, human and a round shape. And then, but still, he needs to understand something in response to him. So generate response is based on video description. This is very important. That's the concept of AVSD. So Devi and Dhruv's group worked on the BQA. That is a static image. They are trying to let people to ask questions. And then they try to, disambiguate the questions using dialogues. But still, the target is static image. We would like to work on videos, so audio-visual scene-aware dialogue we would like to focus on. So at the beginning, what types of data is appropriate? We decided, okay, human action recognition, SARES data, that is provided by Allen Institute. We annotated that data with 10 question answering. So questioners cannot watch the videos. Answerers can watch the videos. So at the beginning, the questionnaire is really silly, and we have to let questioners know about some ground knowledge. So first frame, middle frame, last frame, we show that one to questioners, and they can grab some meanings. And they start to ask much more reasonable questions, and we collect the data. That is the result. And sometimes, how does the video begin? Like abstract level questions was done, but object recognition-based question answering. And of course, that data is human action data. So action is, what does he do? Like this type of question is in there. And also pronoun is in there to confirm the previous sentences. So it means that slightly dependent each other. And audio side, especially we would like to focus on audio visual fusion. So they would like to confirm speech or noise or pet or any other information they would like to confirm. This is very good. And we built the baseline system using a multimodal fusion, audio visual fusion, and question answering, everything put into the one pot to generate the answers. And this is a performance. We got the 9 teams they submitted 32 systems. And we evaluated 13 systems by 5 humans. And Blue 4, we sorted the result based on the Blue 4. Actually, human rating corresponds to that Blue 4. So I would like to invite all people to Hawaii. So January 27th, we'll have a workshop. And Holger Schwenk will give a talk about the language model, natural language processing, which will contribute to the dialogue technologies. And still, registration is open January 2nd. And of course, the most important things, DSTC 8, we would like to invite, we would like to call the proposals here. So especially I talked with the poster presenter, they are working on a sentiment. So I think next year, if we have the sentiment-based dialogue challenge, it is very nice. So please submit the proposal to us. Thank you very much.
Questions, I guess, to all the speakers? Okay, let's thank all the speakers again.